Hello everyone, welcome to Basic Electronics video lecture sessions. In today's session I am going to explain the rectifiers of chapter 1. Actually the rectifiers are the diode circuits. What is the function of rectifier? The rectifier converts AC into pulsating DC. So let's continue with the types of rectifiers. There are two main types of rectifiers. One is half wave rectifier and another is full wave rectifier. The full wave rectifier is again divided into two main types. The first one, that is full wave rectifier with center tap transformer, and second one, that will be the bridge rectifier. In this lecture, I am going to explain the full wave rectifier with center tap transformer in detail. So let us see the polarities of center tap transformer voltages. So before connecting and designing the full wave rectifier using center tapped transformer, we need to understand the basics of center tapping transformer. Always we know there is a step down transformer we will use, and this is the center tapped transformer. According to the center tap transformer, you can see easily there are three terminals at the secondary transformer. At the primary, if you will apply positive half cycle, then the line and neutral voltages will be plus and minus. According to this input positive half cycle, at the output, at the secondary half of transformer, we will have the three terminals A, B and O, which is the center tapped terminal. If positive input cycle is applied, then the output will be positive only for the upper half portion of the center tap transformer. Look at this. This is the upper half portion of the center tapped transformer. It will be across A, O. So A is positive and O is negative. Similarly, if input is positive half cycle, but if I am going to measure and collect the output waveform for the lower half of center tap transformer, then O becomes positive and B becomes negative, and so I will have the reversed polarity of the output, so it will be the negative portion of the cycle. Similarly, let me explain the negative half cycle of the input. If you will apply the negative half cycle at the input at the primary of center tapped transformer, then what happens? So that line and neutral voltages will be reversed, minus and plus respectively. But at the secondary terminal side, again we will have the idea of three terminals A, B and O, that is center tapped. We will have the two portion of the output, upper portion and lower portion. So for the case of negative half cycle, we will have same negative output for the upper portion of the output, center tapped transformer. Similarly, at the lower portion of the output, across the center tapped transformer lower part, we will have the output, it will be reversed, it will be the positive half cycle. Similarly, again I am repeating that during positive half cycle, for upper part of the center tap transformer, we will have the positive half cycle, and during negative half cycle, if input is negative half cycle, then output at upper part of center tap transformer will be negative, and in another portion it will be reversed. Now look at this. This is the full wave rectifier with center tapped transformer. I have used the polarities and concept of center tap transformer using two diodes here. We require two diodes D1 and D2. According to the circuit, look at this. This is the circuit of full wave rectifier with center tap transformer. Here, one resistance is required. Which are the main components? Two diodes and one load resistance. Input is applied to the primary of circuit diagram and output will be collected at the load resistance. So this is the circuit of center tap full wave rectifier using two diodes. So now let us see the working of full wave rectifier using the center tap transformer. The operation of the full wave rectifier using center tap transformer will be divided into cycles during positive half cycles and during negative half cycles. So let me explain the case 1. During positive half cycle, how the current flows. Okay, again look at this. When positive input half cycle is applied, P1 and P2, there are two terminals of the secondary of transformer, top and bottom. P1 becomes positive and P2 becomes negative. But due to the center tapping and due to the input terminal is P1, the diode D1 is closed switch and D2 will be open switch. Thus, D1 acts as a short circuit and D2 acts as an open circuit. So, the current will flow from P1, D1 through load resistance towards the center tap transformer. It will be O. Let's assume the center tapping is O. So according to this, the current flows from top to bottom through load resistance, right? From plus to minus. Now let us see the operation of full wave rectifier. The operation or working of any of the rectifier, it is divided into two cases. The case 1, that is during positive half cycle, and case 2, that I will explain during negative half cycle of the input. So look at this. This is the circuit diagram of full wave rectifier with center tapping used in positive half cycle. So let's discuss the case 1. During positive half cycle, there are two main terminals of the secondary. P1 becomes positive and P2 becomes negative. Due to this polarities of P1 and P2, we have the two diodes D1 and D2, but D1 will be forward biased and D2 will be reverse biased. So that D1 diode acts as a closed switch and the D2 diode will act as an open switch. So through D1 current can flow and through D2 current cannot flow. So what is the direction of current? That is important. So let's draw the current flow during the positive half cycle of the input from P1, D1, RL to the center tapped transformer O. Assume the center tapping, that is C or O. So what is the current path? P1, D1, A, RL, C. At the center tapping, at the center point, right? Finally, during positive half cycle, we will have, this is the output. If input is positive half cycle, output will be positive. Now, let's draw the waveform for positive half cycle. First of all, we will draw the two axes for the input voltage and output voltage during positive half cycle. If we will apply the positive half cycle at the input, then what we have studied, what I have explained, D1 is on and D2 is off, as D1 is forward biased and D2 is reverse biased, so that the current flows from P1, D1, RL, C at the center point of the secondary transformer. The current flows from top to bottom and we will get the output across the RL, so final output will be same as the input, so that output follows the input. Now let us study about the negative half cycle input. In next negative half cycle of the input, what will be the operation of wave rectifier? Again, as input AC signal is negative, then what should be the current direction? It will be also reversed. But how? That is important. As input cycle is negative, then what will be the condition of diode D1 and D2? Diode D1 will be open circuited and D2 will be closed switch, because D1 will be reverse biased and D2 will be forward biased. Thus, during negative half cycle of the input, P1 becomes minus and P2 becomes plus, so that D1 is reverse biased and D2 is forward biased. So that D1 is open and D2 is closed. Always current starts to flow from positive terminal. So let's draw the current direction and flow. From the circuit diagram, you can see easily that P2, D2, A through RL means load resistance and to the center of the secondary of transformer, at the center tap transformer. Finally, what is the conclusion? The current flows during both half cycles through load resistance from top to bottom. From this concept, if input cycle is negative, then output cycle is positive, because in both of the half cycle, in positive or in negative, the current flows from top to bottom through the load resistance. Right? Finally, let's draw the waveform for negative half cycle. If we want to draw the input voltage and output voltage for negative half cycle, so first of all we will consider the sine wave at the input, and according to that, if sine wave is applied to the full wave rectifier using two diodes and center tap transformer, then during negative half cycle, D1 is reverse bias and D2 is forward bias, and therefore output is always positive, because current will start to flow from bottom terminal, that is P2, but it flows through RL and it goes through RL in only one direction, from top to bottom, from plus to minus, so that output is again positive half cycle. So between pi to 2 pi, during negative half cycle of the input, we'll have the output is positive half cycle. Again, during positive half cycle, we'll not have the output any for only negative half cycle. This is the waveform of only negative half cycle, and again next negative half cycle will get the positive output waveform. Now let's draw the final output by performing both the half cycles for full wave rectifier using center tap transformer. So we will have the two axes, x-axis is the time axis and y-axis is the voltage. Input voltage waveform, that will be the sine wave which is applied to the input of full wave rectifier. So during positive half cycle, we'll have the current output across the RL positive waveform. Similarly, during negative half cycle after pi, then we will have again positive half cycle of the output, because D2 diode on. In alternative half cycle, we will have any one diode will be on. During positive half cycle, D1 will be on, and during negative half cycle, D2 will be on. So that in any of the half cycle of the input, any one diode will be on, it will be conducted, so we can say it is forward bias, and we will get the output across the RL, and it will be always positive, because current flows through the load resistance. It will be always from plus to minus, from top to bottom. Thus, these are the final waveforms for full wave rectifier. In positive or in negative half cycle of the input, we will have the always positive half cycles. Now look at this. These are the final waveforms of V in, I out, V out, and if you want to draw the voltage waveform across diode, then it is known as VD1. Initially the diode D1 is closed switch and then diode D1 is open switch. So first of all, during positive half cycle, if diode D1 is forward biased, then we will get the output Vout is always positive, but across D1, across short circuit during positive half cycle, it will be ideally 0, but practically it will be 0.7 volt, slightly above the 0 axis. Now during negative half cycle, the diode D1 acts as an open switch. So even if the input is negative, output is positive as the current flows from top to bottom through load resistance, but across the D1, if I am going to draw the voltage across D1, then it is open switch, and the voltage across open switch, it will be exactly as the same as input. So thus, during positive half cycle D1 is forward bias, so the output is 0 ideally, but practically it is 0.7 volt if it is silicon, and during negative half cycle D1 acts as an open switch, so output equal to input. Again during positive half cycle, we'll get the practically 0.7 volt, and during negative half cycle D1 behaves like an open switch, so output follows the input. So dear students, these are the final waveforms by combining the both half cycles of input during positive half cycle and during negative half cycle. From these waveforms, we can understand the working of full wave rectifier using center tapping very nicely. So dear students, if you have any doubt from this topic, you can ask me anytime and you can mail me for any query or any difficulties. That's all about today's session for full wave rectifier using center tap transformer. Thank you very much.